Good afternoon. Are you having fun? Yeah, it's a great conference. Thank you for being here in my talk, and thanks for the conference for inviting me to talk in this amazing conference. I'd like to begin with a short story of mine. 5 years ago, I started developing in JavaScript. Until then, I was using PHP for work and MATLAB for science, and I didn't know anything about JavaScript, and I developed enterprise-grade applications all by myself. And then came a time when I needed to connect it to the server. Has any of you ever connected something to the server? I guess so. And what happened was that the application crashed because it was the beginning of the time of big data, and data flowed into my application, and my mock data that was like 100 entities was not enough to simulate the real thing. So I had two options. I could quit and move to another job, or I could face it like a hero, and I am a hero. So long story short, I managed to solve the performance issues. And when I looked at my solutions, I saw something familiar from like 10 years ago when I was, at the time it was 10 years ago, sorry, I'm so old, when I was at the university. I saw design patterns. A thing that during learning them, I said, why do I need to memorize this thing? When would I need to use it actually? And then I saw that I actually redeveloped design patterns while looking for solutions for my performance issues. So that's my story, and that's kind of how this talk came to be, because I wanted to share my experience and hopefully help you understand the importance of like relearning computer science stuff that you might have forgotten, and show you how I learned things from playing games, which is cool. So who am I? I'm Yonatan, also known as @Yonatan Kra. I'm a software architect at WalkMe. I was the CDO of WebEx, where I actually learned everything about JavaScript performance. I was a neuroscientist in my past. I'm developing software since I was in 2nd grade, and I've been meddling with several types of languages. And I'm also a runner. That's one of my peak achievements. I won a half marathon, which was great. And this is one of my 3 best achievements. My eldest son, Itamar, who was running at a later race for 2K at the age of 6, talking about performance. So what we're going to talk about is going to be short. I know lunch is coming and you're hungry. So we'll talk a little bit about motivation. And what I mean by motivation is to learn when and where to use design patterns. We'll look at 3 or 4 design patterns in relation to computer hardware, okay? Because they are coming to solve some computer hardware limitations that can affect performance. And what I'm most interested in is performance in the big data era, when we have a lot of data coming into our clients or even servers. And eventually we'll summarize and you can go eat. Hopefully you won't have a lot of questions. The bane of speakers. Okay, so let's start. Design patterns. As I said, I noticed that I kind of redeveloped design patterns, and it's probable that some of you actually redeveloped them on your own at some point because they come to solve common problems. Common problems is something that most people run into at a certain time. And you actually use them all the time, even if you don't think about it. The moment you do a for loop, you're using the iterator pattern. What I'm most interested in is optimization design patterns, and especially in gaming, because I love to play games. And let's see why gaming. Okay, I'm going to show you a short video and focus on the reaction of the player.
Says stay crouched and follow him. So I'm just gonna wait. All right, we're gonna chase him down. Let's go, boys. Ah, get him off me. Nice, let's go. All right, I don't want to get. Oh my god! Holy shit!
Okay, it gets uglier from here, but it's not vegan friendly. Sorry. But you hear the commentary by the player. He's really into the game. He's like swearing and really into it. And he has a really real life experience. And this is what game developers are struggling with, to squeeze the machine to make the best how do you say it? The best experience for the user. And this is why the gaming industry leads the software world in regards to performance or optimization. So I learned a lot, and I'll show you how this relates to applications. If you don't develop games, it's still relevant to you. And I'll show you a few examples from real life, how I used such design patterns from gaming in web applications. So we had a great talk yesterday about time-driven development, and I really agree with everything that was said there, because we have to consider things when we want to use, this is kind of a disclaimer, when we want to use design patterns or architect something. So we need to take into account architecture, which is reusability, flexibility, solid, and all that. We need to take into account performance that might contradict our architecture, because sometimes you have to actually hard code something in order for the thing to be performant enough. And eventually we have real life. We have deadlines. We need to deliver value to our customers. And if we delay with the product's delivery, someone might deliver something that covers even part of our product, and our impact will be smaller. So always when you choose a design pattern or architect a software, remember that you need to balance between the three. And now that we know our disclaimer and how to look at design patterns, because I'm going to show you great stuff, but don't run head on to use them, let's dive deep into the machine. So our first station is CPU. Does anyone here knows what a CPU is? No? Okay. So the CPU is the heart of our machine. It does all the computation. We might touch the GPU, but the CPU is like the heart of things, or the brain, or however you want to call it. And let's look at an example for real life of something that can happen in the GPU. So this is CaesiumJS. CaesiumJS is a JavaScript library that brought Google Earth into like native web. It's written in JavaScript with WebGL, and it's really amazing. And let's say we write an app for the Washington, D.C. Veterinarian that helps him track cute cats all over D.C. We all like cute cats, right? So I got my mock data of around 100 cats, and it works amazing. And I show the picture of a cat and a label of the name of the cat and some ellipse that shows the squared error of its position at any given time. But then I give it to Washington, D.C., whoever, municipality, whoever uses it, and they connect it to all of their cats, and they're very rigorous, so they actually connected a lot of cats to this system, and the app crashed or started to be unresponsive. And users said they can't use it. And some users said that his laptop's fan started working like crazy. And it happened to me as well. So we have a problem, and we need to solve it. And the first thing you need to do when you have a performance issue is to monitor and see where the problem is. So you can read all about it in this blog post. This actually describes the problem itself. But here's a summary. During monitoring, what we see is that half of the time, without any user interaction, just showing the application on screen, the CPU, or the thread for that matter, was busy half of the time doing some computation. And you wonder, if nothing is moving on screen, why are you thinking so much? So I looked deeper, and I see that Caesium has something that's called a rendering cycle. And it's kind of the same like in computer games. And why is that? Because every frame, Caesium calculates for every entity in the map where it's supposed to be, what's its color, what's its image, and stuff like that. And digging even deeper, we see that two methods, the billboard and the label updates, take the longest time. And this is probably what's getting the application stuck or even crash. So looking deeply, I won't show you the actual code. It's pretty complex. But eventually what happened was that we had 50,000 cats to track, but only 600 cats were updated per second. Okay? And the rendering cycle was actually going over all of the 50,000 cats and process their data, even if it didn't change. So we can define a problem or generalize a problem by saying that if we have a lot of data and a heavy processing procedure for each unit, we wouldn't like to go to process all of the units if we already processed it and it didn't change. Okay, and here comes the dirty flag pattern. You probably heard of it or even used it. But I forgot about it, and I kind of reinvented the solution. And the solution is, you can read about it in this blog post, but the solution is pretty simple. What we need to do is when we get a cat, we update the cat and then set a dirty flag to true and tell Caesium rendering engine, if you see a dirty flag true, process this unit and then turn the dirty to false. If it's not true, just skip it. Okay? So this is what happened before. And after applying this solution, it's pretty drastic. We went down to less than 2% CPU usage. Okay? And now the app can respond to user interactions, do other computations, animations, micro interactions, and whatnot. And we actually free the CPU to do whatever. So we know the problem is, we know the solution is, and the algorithm, we already described it. Just set a dirty flag and tell your rendering cycle what to do. So let's summarize what we've seen. So when to use it? You use it when you have a lot of data and you have a costly processing procedure, and you don't need to update all of your entities all the time in every cycle. We saw the importance of monitoring. So you have to monitor to see if your solution works or even if it fits to your situation. And more examples from real life are, for instance, change detection mechanisms. If any of you used AngularJS, anyone? I'm sorry for you. And sorry, I actually did it a lot. And Angular as well, and Backbone. And actually, I think most of change detection mechanisms have some, I'm going to say, digest cycle that runs over all of the things that you track and say, has that changed? If it's changed, I'm going to broadcast the change or whatever mechanism it does after that. Okay, but the idea is the same. Some cycle that's running, rendering or whatever, and it tracks a lot of data, and it needs to know what to process and what not. And you can read about the problem and the solution in these links. I'll send the slides later. The next part we're going to visit inside our computer is the memory. So everyone knows about memory leaks. It's pretty obvious. But memory allocation is something that especially JavaScript developers, which is a very high level, don't really care or know about. And in order to understand that, let's see a short video. I hope it'll work. Of why it matters.
The allies carefully in the Syndicate, now available as part 3 of the Earthrising expansion for Star Control Origins.
Okay, so this is not a first-person shooter, but you see all the explosions around the spaceships, all the lasers firing, all this scenery coming and going. They're very dynamic, and just so you know, every not pixel, but every part of the explosions, for instance, is an object that is describing this part of the explosion. This is what gives us all of the nice effects. And actually, if we naively just do new to the object, or the class for that matter, every time we need to create a part of the explosion will cause a performance issue. And let's go over 2 concepts that will explain that. The first is allocation. Okay, what is memory allocation? Every time our software requires to store data of some kind, it asks I'll simplify it a lot. It asks the OS, the operating system, for some memory. Okay, so let's say we have some data, and then we want to create an array of 5 members which fits right into near the sum data. And then we want to push to that array, but because we don't have anywhere to push it, the system needs to allocate new place in memory for that array. Just copy the array over there and add the new array, the new element. Okay, so this is allocation, and it takes time. So if you need to create explosions that do something with animation, for that matter, it can just show jittery, and the user experience will be hurt by that. The second term is fragmentation. What is fragmentation? Let's say we instantiate a cool thing, and then we instantiate a lousy thing because we want to try it anyway. And then we instantiate a new cool thing. And we really like our cool thing, but we don't really like our lousy thing, so we remove it from memory. And then we have a gap in memory, and this is called fragmentation, because if you remember the former slide, if we want to add an array, it might fit in between cool thing and cool thing 2, but then we want to expand the array, we have, again, the allocation problem. So these 2 problems, or these 2 terms, kind of like emphasize each other and work together to cause you problems. So the solution is called object pool, the object pool pattern. Yeah, no, I really like this image. So yeah, the solution is not to actually create your objects underwater. The solution is to recycle. Okay, the environment is very important for us, so please recycle. But object pool says something very simple. You pre-allocate an array of the objects you need and just reuse them. You don't create and destroy instances of the class. And let's see how it works. A very simplified example. Don't use that in production, please. In the constructor, you create the pool, an empty array, and then you just instantiate it with, let's say, initial size, which is 5,000. And now we have an array of empty objects, empty new objects that are all dead or alive false. And in order for the user to use one of the objects, we expose an API that says get new. If you're sharp, you'll see that it's not the most efficient algorithm, but I had to simplify it so it will enter one page. But eventually, we'll look for the one that is dead. We revive it, give it to the user, and when the user finishes, let's say when the explosion is over, we release the object, and it's ready to be used by the next explosion. So you might say it might not be so important to do that, so that's why I've created a live example. So let's try to use something like that. Can you see the things that are, okay, yeah, you see. So you can see that with the pool, it runs almost around half a second, and without the pool, it takes much longer. Okay, so the pool might be very important even if you have only data. Nothing was moving on screen, but even for your computations, let's say it can save you on EC2 instances or computing power or whatever computing power you're using, even server side. Okay, so this pattern can be very important if you're running into a case in which you have a lot of create and delete with a lot of objects. If anyone wants, I can send the code on GitHub. So we said when to use it. Okay, a lot of objects, a lot of create and delete processes, and it creates memory allocation problems, which stalls our application. The cons and pros, again, you need to consider architecture versus performance. You create a new system that you need to maintain. Okay, the whole object pool is a new thing, a new API you need to maintain. You need to show your developers how to use it, make sure they use it correctly, and et cetera, et cetera. And more examples. There are several examples. One of them can be with, again, we'll go to Caesium, and let's say we know we're going to have 50,000 cats. No, the cats might not be a good example because we like cats. Let's say we have something that can be deleted, and let's say we have some polygon that is an area of a party, and we want to show only the people that are inside the party. So everyone that goes out of the polygon is being removed, and everyone that gets inside the polygon is being shown. So we create 10,000 objects and just reuse them all the time when someone goes out or goes in from the area. Okay, I hope it's clear. Okay, so we go to the next station, which is the connection between, it's written here, but can anyone say what's the connection between memory and CPU? Nobody? The bus. So, what's the bus? The bus in the computer, let's see what it is. First of all, let's say something about memory and CPU. CPU is very fast in comparison to memory, and the gap grows. Okay, that's not my chart, but this is how it goes, and this is how we have to live with that. So let's say the CPU gets some request to compute something, and it needs data from the memory, so it asks the bus to give the memory a ride from a certain address, and it gets the data and it processes it, and everybody's happy. Okay, so we have an old bus. But that's not enough, because what happens is that if the CPU calculates something and then it finds out it needs data that was not brought by the bus, it goes back to the bus, tells it, go to the memory, ask from the slow memory to find something, and bring it back to me to continue the computation. And this means that the CPU sits idle, and if your application is time sensitive, that's a problem. So we have modern buses that implement cache. And what cache means is it's kind of heuristic that, okay, I ask you for a part of the memory, but the bus also brings a bit from the side from the memory that is requested. Okay, it's a caricature. If you want to read it in more details, Wikipedia. But there is a problem. The cache can still miss, like the old bus missed. And this can be a problem because how does it look? The CPU asks for the memory. It starts doing the computation. And then during computation, it finds out that it needs this part of the memory, but the cache limit was up to almost the memory we needed, and we had a cache miss. Okay? And why is that a problem? Because if you look at these examples, let's not get too much into the code, but eventually what's happening here is that we linearly go over the array. So we ask to process units that are closer to each other in memory, or we process the array, let's say from the first, then the thousands, then the 2000s, and so on. And then we process every time units that are 1,000 indices far away from each other. And you can see that when we do that, it's 90% slower than parsing the array in the linear order. Okay, and that means the data that is closer to each other in memory will have a faster processing time. And this is very important, not only in games, but for you, whether you develop front-end or you develop some backend application that processes a lot of data. And you can say, again, you can save CPU time, EC2, or whatever, Google, whatever you're using, and perform much faster. If you will soon see some solutions. So we said what the problem is. Data that is not closed in memory is processed much slower. And the solution is kind of use case specific, because you know your data. You know what data needs to be processed together. And you might need a solution that sets a hot and cold array, that you know that the hot array is something that is processed a lot together and the cold less, or you sort your arrays of data according to some meaningful way that you know that the data is going to be processed together. And there are many solutions for that. But just know the use case and type in data locality, and you'll probably find even some libraries that help you do that. Just like actually object pool has the same. So we said when to use it. When we have a lot of data, performance is very important for us, and we know how the data will be processed, or what data needs to be processed together. Cons and pros. Again, it's very hard to maintain. Let's say you need to do sorting all the time on your data according to some complex algorithm that knows how the data will be processed later. So it can be costly, but you need to consider architecture versus performance, and of course, deadlines. And now the part that you most like, because we're going to eat. So we learned about motivation, when to use it, and the considerations you need to take. Even though we saw examples that were amazing in their performance improvement, you might not always need it, okay? And remember that you have an overhead of using these patterns. Remember to monitor. The moment you run into an optimization problem, monitor first to know where to fix the problem. Don't just flail with your hands and like I did when I started. Actually, it wasted a lot of time. And I hope that this talk, if you didn't so far, piqued your interest into reading more and refreshing your memory in computer science, or in this case, kind of basic computer science, because these are design patterns that are taught, I think. I learned it during my BSc. And know that it helps. Okay, I hope it motivates you to learn and refresh, and even initiate your junior developers to get more involved in computer science rather than be on your day-to-day job needs. So thank you for listening. It was very fun. I hope you learned something.